Everybody knows the International Space Station, the majestic marvel which houses astronauts from all around the world, and astronauts will continue making trips there for hundreds and thousands of years to come, right? Well, no. The ISS's orbit will start decaying in 2026, and it'll eventually crash in 2031. But how can an orbit decay? Well, you guessed it, it's because of orbital decay. Orbital decay is when the lowest point of an object's orbit, the periapsis, slowly decreases because of the object itself slowing down. It affects the smallest of satellites that are sent to space to even the largest of stars in the universe, as well as comets, planets, and more. But what even causes orbital decay to happen? Atmospheric drag. When an object goes through the atmosphere, it slows down, decreasing the object's orbit. Some examples are the ISS and the Hubble Space Telescope. Alright, that's fine, but the ISS and the Hubble are in space, so there's no atmosphere, right? Wrong. Even though the Kármán line, the border between Earth and space, is at 100 kilometers, the atmosphere extends not 50 kilometers, not 100, not even 500, but approximately 1,000 kilometers above Earth. So, satellites within 1,000 kilometers of Earth will experience atmospheric drag. Even if it's super minuscule up there, it will eventually decay the orbit of the object. And it'll decay faster and faster until it reaches the inner atmosphere, where it burns up and ceases to exist. And on top of that, solar effects can also cause orbital decay. If there's an increased amount of solar activity, the density in the low Earth orbit region will increase, so satellites will experience orbital decay. But we haven't actually experienced any satellites that have unexpectedly fallen back to Earth, right? Surely the space agencies would plan when the satellite re-entry happens. Well, NASA, the largest space organization in the world, messed up big time. So basically in the early 70s, NASA launched a space station called Skylab, and it accomplished a lot of things. Fast forward, NASA was planning to reboost the space station so that it would fall back into Earth. But NASA made a huge mistake. Remember how solar activity can affect orbital decay? Well, NASA discounted that. Another organization did calculations and found out that it was supposed to fall back to Earth in 1979, years before NASA predicted it would. They realized that they couldn't reboost the space station, so they planned a re-entry, which went horribly wrong. They tried making it crash in the waters under South Africa, but there was a 4% calculation error, which made it crash in the middle of Australia instead. This incident was a huge learning for NASA, and it's literally why orbital decay is so important. If we don't calculate it, then it could be deadly. Now, these methods of orbital decay only affect small satellites, but did you know that literally moons will eventually crash into their host planet? It's all because of tidal effects. Basically, massive objects create tidal bulges on their host planet, like with the moon and the Earth. So if these massive objects either orbit their planet the opposite way their planet rotates, or they are under a synchronous orbit, I'll get to that later, then they will eventually crash into the planet. And this isn't uncommon. One of Mars's moons, Phobos, is under orbital decay, but it isn't orbiting Mars in the opposite direction. So why is its orbit decaying? Well, it's all because of synchronous orbit. Basically, the synchronous orbit is an orbit where the moon and the planet will be rotating and orbiting at the same speed. If the moon is under the synchronous orbit, then its orbit will decay because its host planet is literally sucking the rotation out of the moon. If you guys are around in 50 million years, tell me if Mars is still there. And also tell me if a star starts to orbit the sun, because orbital decay can also affect stars as well. When two stars rotate each other, they can collide into each other in a merger event if they lose enough energy and approach each other. But how will stars lose energy? Well, tidal effects can have an effect, but gravitational radiation is also another way. Basically, every single object that has a mass has gravity. The sun, the earth, and even you, but on a very small scale. So, when these two extremely massive objects rotate each other, like super dense stars, neutron stars, or even black holes, gravitational waves are emitted, which are waves that carry energy. That means that massive objects keep losing energy by emitting these waves, so they'll come closer and closer until boom, a merger event happens. Well, that's orbital decay for you. One of the most important principles when it comes to satellites that orbit Earth, because if we don't consider it, then prepare for a man-made meteor shower. See ya.